Hello, good morning. Now we are going to see about the tachometric surveying in the surveying third unit. It is the heading which we are going to deal. It's the continuous of theoretic surveying. In theoretic surveying, we have handled the angular measurement in both vertical and horizontal direction, but still we use the chain or tape to measure the linear measurements. But in tachometric surveying, we are going to avoid the usage of tape and chain with respect to the tachometric principles. Let's see what are the tools or what are the concepts they have introduced in the tachometric survey. The tachometer is also a transit theodolite fitted with stadia diaphragm and analytic lens. The theodolite may vary. The telescope, which may have the format of stadia, has as shown in the figure A, B, C, D, E, F. Any one may be there in the theodolite, and there are different types of leveling staffs we can use. Here the concept comes about the analytic lens. It is an additional convex lens is provided between the eyepiece and the object glass at a fixed distance from the object glass. The purpose of providing analytic lens is to make additive constant, that is the focal length plus the distance, exactly zero. How it is possible? Let's see. Here the advantage of making such condition is it simplifies the calculation by making the additive constant zero. Therefore, there is only one constant which is multiplying constant. Some book refer as K, some book refer as C. The distances are directly calculated by multiplying the difference of stadia has by 100. But the only disadvantage is brightness of the image is much reduced due to absorption of light. And there may be impact of the long distance when we go. The result may be less accurate. Here comes the principle of tachometry and how it avoids the usage of tape and chain. It is based on property of isosceles triangles where the ratio of distance of the base from apex of the triangle and the length of the base is always constant. This principle is going to help in avoiding the usage of tape or chain. In the figure, it is clear that from the instrument position O, when we look upon the staff held at position capital A or B or C with different distance, say D1, D2, D3, the base of the triangle, for example, say the distance S1 or S2 or S3, the ratio is always constant. So with respect to this concept, we are going to get the formula avoiding the additive constant. Here the D1, D2, D3 represent the horizontal distance between the instrument and the staff position, and the S1, S2, S3 represent the staff intercept, that is the vertical distance between the top and the bottom reading of the stadia has in the tachometer. So simultaneously we can measure or we can note down the value of A1, A2 or B1, B2 or C1, C2. The difference between those two, for example, A2 minus A1 gives the S1 value. Similarly, as on. With respect to this S1 value and D1 value, we can easily get the constant, that is the multiplicative constant and additive constant of the particular instrument. If the instrument is also fitted with the analytic lens, we can sure that the additive constant will become 0. The only available will be the multiplicative constant, which is the ratio of focal length of the object and the stadia intercept I. This is the overall concept of the stadia tacheometry. In this, there is no analytic lenses fitted, but we can measure the distance, the linear measurement, with respect to the available stadia has and the lens available in the telescope. But here the additive constant was not avoided, but we can determine those values with respect to the position of the staff held in various stages. The figure shows the concept of lens formula, how it arrives. The following are the terms or notations used in the concept. From the principle of similar triangles, if you refer the previous diagram, there are two triangles we can take, small a1 OA2 and capital A1 OA2. Here the ratio can be equated very easily, that is the I by S is equal to V by U. From we can get V is equal to IU by S. From the properties of lenses, we already know the 1 by U plus 1 by V is equal to 1 by F. By equating this, we have already have the value of V. So we can substitute that value in the equation 2. We will get the equation at the end as U is equal to S by I plus 1 the whole product of F. From the diagram, it is clear that the capital D can be obtained with respect to the summation of U plus small d. So we can substitute the value of U as in the equation 3 in the equation. So we can get finally F by I, the product of S, plus F plus D. Here the F by I and the F plus D are known as tacheometric constant. How it is constant? The focal length of the lens in the telescope, it is a manufactured recent value, and I is also a stadia intercept which was already fixed by the manufacturer. So these two are constant, and similarly the D, the distance between the center of the telescope to the objective lens, it is also freezed. So all these things are not variables, so it is called constant, and the one and only variable is yes, it is the staff intercept. It varies with respect to the distance between the instrument and the staff length. So with respect to that value, we can determine the linear distance very easily. By adopting the analytic lens in the telescope of a tacheometer, we can make the multiplicative constant, that is F by I is 100, and the additive constant becomes 0. However, in some tacheometers, the additive constants are not exactly 0, but vary from 30 cm to 60 cm, which are generally mentioned in the catalog of the manufacturer. Let's try to solve this and determine the stadia interval. The stadia readings with horizontal sight on a vertical staff held 15 meter from a tacheometer were 1.285 meter and 1.780 meter. The focal length of the object glass was 25 cm, and the distance between the object glass and the vertical axis of the tacheometer was 15 cm. Now we need to calculate the stadia interval. How we can calculate? Here the focal length small f is given in centimeter, and the vertical axis of the tacheometer was 15 cm, that is the I also is given in centimeter. And the staff readings were given. One is the top value and another is the bottommost value. The difference between those two, that is 1.780 minus 1.285, gives the value of the staff intercept S. And we know the horizontal distance also fixed, since it is 50 meter given in the problem. It is from the instrument to the staff weld position. So we know the capital D value, we know the S value, we know the F by I. The focal length we know the I value. We know the D value. Only thing we don't know is the stadia interval, that I. So if we substitute the remaining values appropriately in the equation we have derived, we can easily get the value of